Welcome to Capital Considerations. This is Tony Roth, your host, CIO of Wilmington Trust. We've got a great episode today relative to extreme weather. And we've had a number of conversations on capital considerations in the past with global warming and climate change experts, but we've not done an episode which is going to be, I think, as focused and potentially actionable as this episode, which really focuses in on what I think of as the leading edge of climate change, which is its manifestation not as very slow incremental changes to our environment, but rather the extreme weather that's changing our lives. I just want to frame why this is so important from an economic and a fiscal standpoint. So just a few really interesting stats. The European Environmental Agency has estimated that just in Europe alone, Europe has spent about or realized about $500 billion of economic losses over the last 40 years due to climate hazards and extreme weather. And that has been very much backloaded towards recent years. The World Economic Forum has indicated that over the decade 2001 to 2010, about $1.6 trillion globally of economic losses were sustained due to extreme weather. And in the last decade, 2011 to 2020, that number jumped from 1.6 trillion to 2.6 trillion. And then bringing things home, NOAA, which is an esteemed organization of our government, NOAA estimates that about $120 billion per year in the U.S. is the number of economic loss that we're now sustaining on average over the last few years, whereas that number was only around $50 billion a decade ago. So we can see not only the impact of these events, but the accelerated impact of these events. So that's what we're going to talk about today. And I think it's an episode that is going to be fascinating, alarming, but also important. I'm really excited about our guest. Dr. Daniel Swain is a climate scientist at UCLA's Institute of the Environment and Sustainability, focusing on the dynamics and impacts of the Earth's changing climate system. His recent work seeks to understand the risks of extreme weather, such as droughts, floods, wildfire, in a warming climate. Hurricanes, too. You can find Daniel on his blog, Weather West, where he provides real-time perspectives on California's weather and climate. So, Daniel, thank you so much for being here today. We're really excited to have you.
Yeah, thank you for the invitation.
Just want to remind our listeners that Wilmington Trust is nonpartisan, and we're not taking a stance on issues that are maybe highly charged for listeners. We're trying to understand the world in which we live the best we can and to relate those observations and insights to how we manage money for our clients. I think the place to start is to really drill down into this distinction between general climate change and one aspect of climate change, which is this accelerated experience of severe weather. How do you think about that distinction, and why was that so important to you in your focus as a scientist in your work?
I think it's a good question because when we talk about climate change, we often hear about these fairly global or vague numbers and targets and statistics. We hear about 1.5 or 2 or 3 degrees Celsius of global mean warming, or we hear about sea level rise, or we hear about changes happening at the end of the 21st century. And all of these can sound a little bit fuzzy. And I think one of the challenges of communicating as a scientist communicator, my job is both to do the research and to have these kinds of conversations about climate change, is really bringing home the fact that a lot of the reasons why we care about climate change are actually not the top line numbers that we're used to hearing about in newspaper headlines. What actually causes a lot of the harms associated with climate change isn't this relatively incremental warming itself. Instead, this incremental global warming is a heuristic for the other changes that seemingly incremental global change brings about much more dramatically at the local and regional scale. So the reason why it's such a big deal that the Earth has warmed at this point about 1.3, 1.4 degrees centigrade, depending on how you measure it, as a result of human activities, that sounds like a small number, except that that's a geologically enormous number. On the timescale of a century, the Earth just doesn't change that quickly. But it is now because of the human emission of greenhouse gases. And what that 1 and some odd degrees of change so far has already brought about is a significant increase in the occurrence of certain types of extreme weather events. So we're talking extreme heat waves, extreme downpours, certain types of extreme storms in certain regions. And that's where a lot of the damage has come from at this point. Whereas if we've already started to see the significant increase in extreme weather events at our present level of warming, and we're on track to double that, and some of these impacts from that relatively incremental linear warming are themselves not linear, then we're in for a heap of trouble.
So, for example, I was reading my Bloomberg terminal this morning, and it said tomorrow on Friday, Death Valley is going to be 121 degrees. Well, why do I care? I mean, so there's some really rugged animals like scorpions running around that are going to just, hide under the rock for the day. But then I think about, well, places like Powell and like Meade are drying up and there's not enough water. That's all connected, right?
The reason why we care about these extremes, even when the extremes are only a little bit greater than things we've seen in the past. So this often happens during extreme heat waves, for example, where you hear that something is a record high temperature for the date, for the month, or maybe, for the whole region. You might exceed the previous record by a degree or two. And you might say, well, what's the difference? It's just an extra degree or two. But the problem is that human systems, human bodies, first of all, have a certain range of tolerance to extreme events. Ecosystems are adapted to a certain range of temperatures or precipitation or humidity conditions. And sometimes modest and temporary excursions outside of that preferred or adapted range are okay for the human body or okay for ecosystems. They are relatively resilient and they can bounce back from that. But if we start repeatedly making these excursions outside of those preferred zones, then that starts to become a much bigger problem. And in some systems, there are actually thresholds, especially in living biological systems. Coral reefs or the western coniferous forests, there are, for living things, physiologic thresholds in some cases. There is a maximum combination of temperature and humidity, for example, that is survivable. If you're a tree in the forest, there's a combination of dryness and temperatures that will mean that your tissues as a plant can no longer supply water to the leaves. You can no longer photosynthesize. That means that the tree dies.
So let's bring it back to the premise for this conversation. In other words, we know that we need to do something about our emissions, and we're trying. We may not be trying hard enough. We may not be moving fast enough. But we're all at least aware of the problem, which is we've got to cut our emissions and maybe even engage in carbon capture and extract carbon from the atmosphere and do all those kinds of things. But your focus is different than the broader problem, right? You're very focused specifically on these extreme weather situations. So tell us more about your research and your focus as it relates to these extreme weather situations and why that effort, as distinct from the broad global approach to try to eliminate or reduce emissions, is so important.
Yeah. Well, I'll actually tackle the second part of that question first and then come back to the first half. We often hear about the difference between climate mitigation, which would be anything that reduces the amount of global warming that we actually see or reverses it. So that would be emissions reductions, eventually bringing emissions to zero, carbon capture, those kinds of things. Climate adaptation, on the other side of the spectrum, is sort of adapting to the climate changes that have already occurred, which are substantial, and those which we know are either inevitable or likely to occur. And often these two things are sort of framed as being in opposition to each other. And I think that's an enormous mistake because they really exist along a spectrum of climate solutions, and we really have to be doing a lot of both. We can't adapt our way out of climate change because if we don't do enough mitigation, the problem will be so big that it will be so massively expensive and complicated to engage in adaptation that we won't be able to do it in the way that we want. On the other hand, if we only focus exclusively on mitigation, on bringing emissions to zero immediately, then we will kind of miss the fact that we're already starting to experience increases in risk from the warming we've already seen. And because we aren't going to bring emissions to zero overnight, and there will be some additional amount of warming, we won't be adapted to those further changes in climate that are essentially inevitable. So my usual language here is just to really emphasize that we really need to be aggressively pursuing both climate mitigation and climate adaptation simultaneously. But in terms of what I do personally on the research side, as you mentioned, I focus on extreme events in the climate system. And my background is actually in meteorology. So originally was trained sort of as a weather scientist, a weather forecaster even. And that's still a hobby. If you read the Weather West blog or follow my Twitter feed, you'll get a lot of fun weather info along with the little heavier climate stuff too.
On your vacations, do you go chase tornadoes in the Midwest?
It's actually funny you say that because that's what I was doing just yesterday. I live these days here in Boulder, Colorado, which is right at the confluence of the Rocky Mountains and the Great Plains. And so I just took the afternoon yesterday to go watch some thunderstorms over the plains. So yes, that is something that I actively do when I have the opportunity. So I'm a bit of a weather geek on top of everything else. But I think that really informs my perspective professionally as a climate scientist. And so I came into the field from a somewhat unusual direction. I came into climate science from a weather-centric perspective. So I really think about these episodic extreme events from a weather forecasting and meteorology kind of risk management perspective, and then apply that in a climate context. So events that occur on multi-decades or centuries or millennia are sort of dealt with by one group of scientists, and the kinds of atmospheric events that are occurring in your backyard that are relevant to the weather forecast for this week, they're kind of handled by a different group of scientists. And one of my jobs is to sort of bring these two somewhat siloed, disparate groups together because the underlying science is the same. And it turns out that a lot of the important consequences and implications of climate change really do manifest through this changing envelope of weather. I often like to say that climate is weather in aggregate. That is what climate is. It's not just the average of weather, but it's also the extremes of weather over time. And so thinking about climate change as an ever-shifting, ever-evolving envelope of weather and potential extremes, I think really helps hone in on a lot of the risks that are incurred by society and the environment.
So tell us about the premise of your research. In other words, as it relates to extreme weather, what are you focused on, and how can we take that research and learn from it or better understand where we're going or the outcomes of severe weather?
Right now, we're sort of focused on extreme issues in the Western United States, although some of these have a lot broader relevance. We're looking a lot into the atmospheric and climate conditions that favor extreme wildfire conditions. We've been seeing a lot of those, more of those to a greater extent out west in recent years. And at the other end of the spectrum, the increasing risk of mega flood events, which may seem like it's the polar opposite, but they are actually unified by an interesting physical principle that I'll mention in a little bit. But the basic idea here is that the Western US has always been a region prone to wildfire, of course. It's not like that's anything new. But the difference is that climate change is really modifying the background burning conditions. It's making for a landscape that is much more flammable than it used to be. And so what we're seeing are fires that are becoming much larger, and more importantly, they're becoming much more intense. So it's not so much that fire itself is the problem. In fact, if you talk to ecologists, they'll point out that fire in many ecosystems is a necessary and healthy part of those ecosystems at a certain level of frequency and intensity. But the problem is now we're pushing wildfires well beyond those preferred intensity, frequency sort of envelopes. So that's sort of the motivation for looking at the changing climate conditions that increasingly favor these extremely dry conditions that are even drier than the very driest conditions that we ever saw in the 20th century. And, folks often say, well, sure, if precipitation decreases, it gets drier, but that's actually not the main factor that's driving a lot of this. And somewhat counterintuitively, the dominant effect is actually the direct effect of temperature. and how that's increasing the evaporative demand of the atmosphere. So in other words, even if you had no decrease at all in precipitation, but you had a substantial increase in temperature, as we've seen in a lot of places, that essentially increases what's known as the vapor pressure deficit in the atmosphere. You can think of it as the propensity of the atmosphere to act as a giant sponge and extract lots of moisture out of the soil, out of plants, out of bodies of water. If you think of the water balance as a supply side and demand side, the precipitation is the supply side. But if the demand side is increasing and the supply side is staying the same, you've got a problem because they're no longer in balance. And that's the primary thing that's going on out west and driving this increase in wildfires.
Then can I infer that really the point of the research that you're undertaking is, yes, I think probably in the immediate to understand the dynamics of these weather systems better that are giving rise to these severe outcomes, but in a way to corroborate the linkage that exists between broader climate change and these severe weather events. In other words, we can all sit back and look and say, oh, there's more fires in California, there are bigger hurricanes. It must be the consequence of a warmer planet, climate change. But from a scientific standpoint, actually establishing the causal relationship between the broad climate change and the severe outcomes in our existential weather is something that's important to establish, and that's what you're doing. Do I have that right, or am I missing something?
Yeah, that's definitely a big part of it. I mean, it's one thing to observe things changing over time, and it's another to infer causality. We do need to know why things are changing. And this becomes practically important because in a lot of cases, some of the changes are actually counterintuitive. One that's, relatively near and dear, for somebody who works with drought and wildfire on the one hand, but also the risk of extreme flooding on the other, is you might think that a region that is seeing a big increase in water scarcity and drought and wildfire would not be seeing a large increase in the risk of a big flood event. But in fact, the exact opposite is true in most of the West, and especially in California, where we actually find that there is likely to be a very large increase in the risk of extremely severe flood events. In fact, we're currently working on a project called ArcStorm 2.0. It's a modern update of a previous hazard planning contingency scenario for the state of California, looking at what the consequences of a mega flood would be in modern California. We haven't seen one in the past century or so. In the period when all of California's modern infrastructure and industry and urban areas have developed. And so the exposures are potentially dramatically higher, and we don't have a recent memory of it, especially because there's so much focus on drought and water scarcity and fire. There's been less focus on the opposite end of the spectrum, and yet our own research shows that very much is a risk that's increasing, but in the background.
So, okay, here we're getting to something that I think is really important because, again, I started out by describing this sort of malaise that we all feel about the environment. Most of us recognize that there's a problem, but it's hard for any one of us to fix the problem. But what you're describing, Daniel, is that, I'm going to put it in my words, you tell me if this is correct, there are what we might call as gray swan events. There are events that haven't occurred yet necessarily, but we can see them coming due to the work that you're doing and potentially prepare for them. Yes, the projection of those potential outcomes should also cause us all to be better recyclers and better stewards of our environment in the different ways that we know we should be doing. But it also means that we need to be very specifically focused on some of these events that we believe could happen and prepare ourselves for them. Does that sound right?
Yeah, I mean, let me make it really concrete by means of sort of extending the specific example about the risk of a mega flood in modern California. The previous ArcStorm studies did an economic risk analysis, essentially, and found that this would be, and I'm surprised this didn't make more headlines at the time, frankly, found that in 2022 dollars, it would be approximately $1 trillion disaster, trillion with a T, making it by far the most expensive, single most natural disaster to have befallen anyone, anywhere, ever in world history, as far as I'm aware. That's a really big deal. And the reason for that, of course, is because it would not only cause direct harm and damage, but it would completely halt or stall virtually all of California's major industries for 6 to 12 months simultaneously. So you can imagine why the cascading effect would be so enormous globally.
Can you just take us through the weather scenario with a little bit more detail so we can visualize what you're talking about? In other words, how would this actually ensue? Can you just sort of give us the scenario?
Yeah, so the scenario we're talking about, a mega flood in California, it's actually a multi-week sequence of extreme winter storms known as atmospheric rivers. You may have heard of them in the news. But this would be a particularly prolonged sequence of particularly wet and moist atmospheric river storms. And it's sort of modeled after something that actually happened, the Great Flood of 1862. At the time, though, only about 400,000 people lived in California. Today, there's 40 million people living in the same region that 400,000 lived at the time. California is much more flood vulnerable than a lot of people realize. The second most flood vulnerable city in the country, behind New Orleans, is Sacramento, the state capital. Los Angeles and San Diego, most of those metro areas, as dry as they often are, they exist on floodplains. Major floodplains that drain very steep mountains that can capture a lot of water and send it downhill at high velocity very rapidly. Today, some of California's major cities that, if you're outside of the region, you probably don't hear as much about, are in the Central Valley, home now to millions of people and a significant portion of the nation's agriculture. So we're talking about, most of the agricultural regions, most of where a lot of people live, the movie industry, and even in the San Francisco Bay Area. There's, of course, lots of hills, but the Bayfront, most of the major tech industry is right along San Francisco Bay, which would flood many of these facilities. Google is just separated by a 6-foot levee from San Francisco Bay. It's right on the waterfront, for example.
So Daniel, so you're a scientist, you deal with data. So what does your data suggest the probability of this event occurring? And I know there's lots of other kinds of events. You're just giving us one example. What's the probability in your mind, based on your data, that this could actually happen, let's just say, in our lifetimes?
We sort of directly addressed this in a study a couple of years ago, came out in 2018, and we found that between about 2020 and 2060, so over just a 40-year period, so that's not an absurdly far in the future, about a 50-50 chance of a modern recurrence of that magnitude of an event in California. And that's higher, significantly higher than it used to be. And this is sort of the crux of what I'm trying to emphasize here. This is not something that was impossible before climate change. We know it's not because it already happened in 1862. So clearly, you don't have to invoke climate change to be concerned with this level of hazard. But the difference is that when it happened in 1862, it was probably something that really would have happened only once every 100 to 200 years. And indeed, it hasn't happened since 1862. But the problem is, with climate change, that's dramatically raising the background odds. But the question is, how much more will it raise the odds? Because currently, we have some preliminary data suggesting that the risk has probably already doubled from the global warming that we've already seen, but that would still make it a pretty rare event. But if we double it again, or triple it over the next few decades, as appears possible, then that's really going to make it something that is almost an inevitability on relatively short timescales over just a few decades. So we go from something that, if we get lucky, would only happen every couple hundred years to something that's almost certainly going to happen in our lifetime, depending pretty importantly on how much warming there actually is, which sort of gets back to this idea that it matters very much how successfully we mitigate climate change by slowing it down and eventually stopping it. But it also matters how much we prepare for these events, from a risk perspective, because we know it could happen anyway.
And that's what I want to ask you. So let's say that we had a crystal ball and we knew it was going to happen in 2060, in roughly 40 years. And let's further assume we could spend $1 trillion after the event, or maybe we could spend $100 billion today, which even on an inflation-adjusted basis would probably end up being a relatively small fraction of the harm, to try to significantly mitigate the damage that's going to be caused when this occurs. How would we spend that money? Are there different actions we could take from a risk management standpoint to try to prepare ourselves to really minimize that economic loss that you're describing?
Often you'll hear, oh, we need stronger, taller levees and bigger, stronger dams. And in a lot of cases, that just isn't going to be adequate. There's no way we can necessarily build ourselves out of this. Yes, it definitely makes sense to make sure our levees and our flood control structures are as resilient and robust as they possibly can be. And that's going to require substantial investment unto itself. But some of the most effective solutions, and this is sort of a metaphor for lots of things in climate change, are to let nature do its thing in a controlled way. So you've heard about controlled burns and prescribed fire from a wildfire perspective, reducing the risk of catastrophic fires by introducing beneficial lower intensity fires to clear fuel and improve ecosystem health. Well, there's a similar analogy in the flood world where instead of trying to constrain rivers ever more by building taller or narrower flood control channels, you actually widen those channels. You do levee setbacks. You let the rivers meander. You set aside certain areas to flood, knowing that you can't prevent everything from flooding, but you might be able to protect your most important stuff from flooding, critical infrastructure, or downtown areas, hospitals, major power plants, things like that, critical transportation arteries. If you can protect those, then you actually mitigate most of the worst harms in an event like this. And so you couldn't imagine designing a system where you let some areas flood on purpose to save the other regions. And there is a precedent for this working. The YOLO bypass is what has protected Sacramento, for example, for at least in the 20th century, and early 21st century, from serious flooding, because it allows a broad 20-mile wide stretch of mostly agricultural land to flood when the river's high, and that keeps the pressures off the levees that protect the state capital, for example.
So some of this is investing in the right kind of infrastructure to allow nature to take its course, but a lot of it is, if I'm hearing correctly, is just being cognizant in our planning that these are likely events so that when we build the next incremental hospital, as nice as the view may be from the recovery room to see the water next to you, if we set the hospital back 5 miles, we wouldn't have an economic loss when the flood occurs because the hospital wasn't built in a place where we should have known there would have been a problem.
And
it wouldn't actually cost us any more.
Yeah, and
right?
That's one of the major reasons why the costs of disasters are increasing so much from an economic perspective. In some cases, yes, we are seeing more extreme physical hazards, but in a lot of cases, the costs would be increasing anyway because we keep building more homes, more structures, putting more people directly in harm's way. This is true along a lot of the world's coastal regions. They're susceptible to hurricanes and storm surges. We keep building more homes in river floodplains. There's all sorts of developments out west right now going up in the absolute highest fire risk corridors. So you don't seem to have learned that lesson yet. There's lots of conversations about it, but historically we've done a really bad job at preferentially putting a lot of value directly in the places where it's most likely to wash away or burn up.
So this is fascinating. Now, let me ask you, Daniel, we tend to be very ethnocentric or localized in our perception of the world. If you could go anywhere, where would be the most active, fascinating place to drop you to study the manifestation of climate change as severe weather? Because it seems to me, given my micro view from as an American, that it would be right where you are. That our west coast and our east coast, fires, hurricanes. Maybe I'm just not listening to the news everywhere else in the world. I don't see any countries that are really taking it on the chin like we are.
Yeah, I think part of it is, as you mentioned, there is some centrism, media centrism. Even the global media even has a bit of a U.S. focus a lot of the time when it comes to these sorts of things. And there is a little bit of insularity in this sort of understanding. I mean, it's not as if the U.S. is in any way unique in terms of the exposure or the kinds of changes that we're seeing from an extreme climate perspective. But they're just much better studied and publicized here. There are the same things happening in Africa and South America and in South Asia, in large part. It's just that the social context is different in a lot of cases. So we don't hear about them as much, and the consequences can be different. Now, of course, worsening physical hazards. So if you see stronger hurricanes or more intense wildfires or larger floods, those don't help you anywhere. It's always a bad thing to see that. It doesn't make anyone better off when these physical hazards get worse. But you can really offset or mitigate or even reverse some of the risks by being smart, or by, in some cases, unfortunately, it's a matter of being lucky where you are in the world. Some places there isn't enough wealth, there aren't functional governments, or there aren't opportunities to have that level of resilience that we have in the US and that much of Western Europe has and Australia has. For me personally, the Western North America, given my focus on fires and floods, there really is no better place to be looking at these sorts of things, because it is a global epicenter, certainly, of the changes in wildfires. One interesting thing you don't get in the Western U.S. are some of the changes that are going on in the Arctic, which are incredibly dramatic and shocking. I mean, even as a scientist, I think it's fair to say that the changes we're seeing in the Earth's, in the northern hemisphere polar areas are incredibly large and incredibly rapid from a geophysical.
And that relates to lots of things. I mean, it affects the immediate ecosystem. Polar bears don't have enough food, the way the whole hierarchy of the ecosystem works, but you also have that may be the principal locus, if you will, of sea rise, right? With those glaciers melting. And so that all comes back to affect all of us around the planet. It's all interconnected.
It is. And what happens in the Arctic, it's now a sort of a joke, but not really a joke in the geophysical community. What happens in the Arctic doesn't stay in the Arctic. I mean, literally, that's true on two really important levels. One, the warmer it gets in the Arctic, and the Arctic is warming 2 to 3 times faster than the rest of the world. So, we're globally at about 1.3 degrees. The Arctic is already about 3 or more degrees of warming so far. So they've warmed much faster.
And that's Celsius again, right?
Yes. I know it's always a little bit difficult to context switch between the science, but the point is, as the Arctic warms much faster, 2 to 3 times faster than the rest of the world, not only is that obviously inducing profound changes in the ecosystems up there, but it also means that as wildfires march northward in the Arctic, so we're seeing wildfires much further north and with much greater intensity and severity than we used to see at these very high latitudes, that's emitting a lot of carbon back into the atmosphere. So it's actually causing even faster global warming. We're seeing the permafrost up there thaw. And as the ground is no longer permanently frozen, we're seeing all sorts of soil microbes start to pick up their activity and start to generate methane, which is, you guessed it, another greenhouse gas. So the more the Arctic warms, the more that we warm at our latitude. And there's some other changes too. There's emerging evidence that some of the fact that the Arctic is warming faster than the rest of the world, long story short, a lot of the world's weather is driven by temperature differentials. Well, if one place is warming faster than other places, you're affecting that temperature differential for the rest of the world, which means that you may be affecting weather patterns in the rest of the world. So there's all sorts of ways that the Arctic is actually starting to feed back in this sort of vicious cycle process back to the kinds of conditions that we're experiencing wherever we live in the more temperate latitudes. And so that's one sort of conspicuous area that's interesting, that's a little bit far afield from where I do my work, but I think is actually quite relevant to all of us.
We're investors here, and we try to think through some of the impacts of these phenomena in our environment and how they should inform how we invest. So obviously, from a macroeconomic standpoint, we're thinking about industries. We're thinking about industries that may not do well. So certain agricultural industries, for example, maybe almonds are not going to do as well. Then there are other ones that will do quite well, maybe batteries, because batteries are going to be increasingly critical to store energy as you have events like we had in Texas, where everything went offline due to the hyper cold that they experienced, or the opposite could occur even in this week potentially due to their heat. They may lose their electrical grid due to too much demand from an air conditioning standpoint. When you think about it, understanding your profession is not investing, but what are some of the things that, some of the very concrete applications or specifics that you would sort of counsel us to maybe be focused on?
I think there's sort of 3 broad classes, and I'll cover them each quickly. The first 2 are actually aligned with what I mentioned about this seeming tension between climate mitigation and climate adaptation, but the fact that there's not really tension at all, and they're actually quite complementary. On the climate mitigation side, batteries would be an example of that, for example, because that's a technology that facilitates much greater use of renewable energy, of zero carbon transportation and things like that. So that's a potential sector where the primary benefit societally and climate wise is that you're working to facilitate a world where we slow and eventually halt global warming itself. And then there's this second class of things which are sort of on the climate adaptation front. This would be anything that really helps us to reduce the consequences of the global warming that's already occurred and that we know is going to occur. This might be anything that helps mitigate or hedge against the risks of extreme weather, for example, anything that makes it less damaging to incur losses that are lower than they otherwise would have been. So here, you're directly trying to engage with things that either make society more resilient to extreme weather or whatever other hazards they may face, or somehow make it easier to recover from those sorts of adverse events when and where they do occur.
So that would be building the structure away from the floodplain, away from the locus of where the bad event is going to occur. Are there other things in that category?
For example, in the West, with respect to wildfire, there's a lot of interest in fire resilient building construction now. So, that's something like how you build structures matters as well as where you build them. So that's a question of, do you spend 5 to 10% more? And sometimes it really is as little as that much to make a fire 2 to 3 times less likely to burn down in a wildfire. It would seem to me that in certain places, that's a very good investment. In other places, maybe it's not as important. But there are similar things that you can do for other sorts of hazards, building structures, or even developing neighborhoods or urban areas in ways that make it safer or easier to shed heat, for example. So you might still need to install air conditioning, but you might need to use it less, and you might strain the electrical grid less if buildings are designed to passively shed heat more easily, for example. This third category, where I think it's a bit of an unexploited area, and it's not so much directly aligned with the category 1 or 2 that I just mentioned, but it's more a caution, something that I see when a lot of the academic and scientific work is translated into industry. And I do occasionally advise folks on this because there's a lot of interest, and I think there's a pretty wide disconnect. There are a lot of people and institutions spending a lot of money to use climate information very poorly. So it's one thing to want to incorporate information on climate change and extreme events. It's another thing to do so in a way that actually is correct. And you can imagine if you do it incorrectly, you might actually be maladapting. You might be doing the opposite of what you needed to do to hedge against the risks that are actually emerging. And I bring it back to this example from earlier where there's a lot of folks in California who are hyper-focused on drought and water scarcity, understandably, because that's what's going on right now, and it's quite severe. But a lot of those adaptations are the opposite of what you would do if you were really concerned about the increasing risk of a very destructive flood event. And so what I've been counseling people to do in that context, for example, is how to engage in infrastructural or personal, professional, institutional investments that can accommodate both, where you are increasing your resilience and hedging against water scarcity, but you're doing so in a way that doesn't increase your exposure to floods, for example, or maybe even actually makes it so that you can hedge against both at once. And this is sort of coming back to this idea that you can design, at least at large scales, you can design systems that bank water in the dry times by allowing regions to flood during the wet times. And so that both reduces your risk of flood damages when it's really wet and gives you an extra supply of water when it's really dry. That's just a very broad example. It's difficult for individual institutions to necessarily accomplish that because that's at large scale. But there are similar sorts of things that are going on in a bunch of different sectors where if you're preparing for the wrong thing, it's just as bad, if not worse, as not doing anything at all.
So what would be a specific example, whether it be how California is adjusting to the extreme, they're not allowed to water their lawns only once a week. Is that the wrong thing to do? Or what are the things they're doing wrong versus what they should be doing, whether it's that example or a different context, whatever one is you think most vivid for us to grasp?
Well, I think at a large scale, California, for example, and really a lot of states in the West are really focused on how can we store more water? How can we use less water right now? Because there isn't enough to go around. There's no obvious foreseeable, immediate foreseeable future where this is going to improve. So there's this very myopic focus on we need more water. We need to find ways to store that water and ways to use that water more efficiently. Using that water more efficiently is always a good idea. I don't really think there's downsides to that. But let's try and store more water in more places. This is where there are potential downsides that I think are being missed and potential opportunities that are sort of being neglected because of this focus on. And so, for example, right now, in California, there's a lot of use of groundwater pumping for agriculture. A lot of the aquifers in California are running dry, essentially, because there's no longer surface water in the reservoirs to supply to agriculture. So individual well drillers are just sticking a bunch more straws in the ground, essentially, and sucking out that ancient water that out of these aquifers that is not easy to replace. Once you get rid of that space in the aquifers, it doesn't necessarily come back. So it's a non-renewable resource. But you could imagine that if you were thinking about drought and flood at the same time as hazards that are both increasing over time due to climate change, you might think, okay, well, if it's going to be drier most of the time, but occasionally much, much wetter in these episodic destructive bursts, is there any way we can harness those otherwise destructive huge pulses of water to sort of hedge against the drought risk? Can we essentially bank that excess water underground on the random occasions when it is available? And the answer is yes, if you design a system that can actually direct those floodwaters to places where they're going to recharge the aquifers. You won't be able to do it every year, but when the opportunity arises, it's an incredible opportunity to suddenly just erase 5 or 10 years of water pumping during a drought. And simultaneously, you get to say, well, we saved the city of Sacramento from flooding because all that water went somewhere else. Oh, look, now we're set for the next drought too. But that isn't going to magically happen. We currently do not have the systems to make that happen. It's very likely that if this very big flood event were to occur next year or in the next decade, for example, that it would cause huge devastation in the meantime, and then we'd be right back to drought 2 years later, and we wouldn't have really gained anything from it. So it's a question of time horizons and thinking holistically about the whole spectrum of what's possible.
Well, we have to end. It's been fascinating, but the thing that to me, and I'm not sure I really got here until the end of the conversation, Daniel, but the thing to me that was really powerful about this conversation and has really changed my perspective on climate change is that the major geopolitical dialogue is focused on mitigation. It's focused on mitigation specifically of emissions into the atmosphere, and that's going to be critical to the future of the planet. But there's so much we could do from a adaptation / preparedness standpoint that I wasn't really aware of. And that, it takes some fortitude to take the money out of the bank and spend it today in order to be in a much better position when that extreme event occurs later. And it could be something really obvious, like putting the right barrier in front of the Hugh Carey tunnel that feeds New York City, which flooded disastrously during Hurricane, I think it might have been Sandy. Or it could be something that's much more subtle and requires sort of the science that you bring to the table with your colleagues to understand, how do you actually divert the potential floodwaters into the aquifers. But having that perspective is, I think, going to be so important for us as we move forward as citizens and stewards of the planet, but also as investors. Because when we think about mitigation, we have thought a lot about things like battery technology, and we take that into account in our portfolios. I'm not sure that we've been as sensitized to kind of the infrastructure needs that may be coming down the pike over time to make us more prepared and to adapt to the climate change itself. So for me, that's been a really fascinating eye-opener from our conversation today. So thank you so much for being here. It's been just great.
Well, thank you again for the invitation. And I totally agree that I think that really we do need to be able to walk and chew gum and work both on the climate mitigation side as well as the climate adaptation side simultaneously. So thank you again for having me.
I want to let everybody know that we're going to take about a 3 or 4 week break in our cadence of developing and producing podcasts for a bit of an early summer break here. So with that, thank you again, Daniel, and I wish all of our listeners a wonderful day.
This podcast is for information purposes only and is not intended as an offer or solicitation for the sale of any financial product or service or recommendation or determination that any investment strategy is suitable for a specific investor. Investors should seek financial advice regarding the suitability of any investment strategy based on the investor's objectives, financial situation, and particular needs. The information on Wilmington Trust's capital considerations with Tony Roth has been obtained from sources believed to be reliable, but its accuracy and completeness are not guaranteed. The opinions, estimates, and projections constitute the judgment of Wilmington Trust as of the date of this podcast and are subject to change without notice. Wilmington Trust is not authorized to and does not provide legal or tax advice. Our advice and recommendations provided to you is illustrative only and subject to the opinions and advice of your own attorney, tax advisor, or other professional advisor. Diversification does not ensure a profit or guarantee against a loss. There is no assurance that any investment strategy will be successful. Past performance cannot guarantee future results. Investing involves a risk, and you may incur a profit or a loss. Any reference to company names mentioned in the podcast should not be construed as investment advice or investment recommendations of those companies. Facts and views presented in this report have not been reviewed by and may not reflect information known to professionals in other business areas of Wilmington Trust or M&T Bank, and may seek to provide financial services to entities referred to in this report. M&T Bank and Wilmington Trust have established information barriers between their various business groups. As a result, M&T Bank and Wilmington Trust do not disclose certain client relationships or compensation received from such entities in their reports. Investment products are not insured by the FDIC or any other governmental agency, are not deposits of or other obligations of, or guaranteed by Wilmington Trust, M&T Bank, or any other bank or entity, and are subject to risk, including a possible loss of the principal amount invested. Wilmington Trust is a registered service mark used in connection with various fiduciary and non-fiduciary services offered by certain subsidiaries of M&T Bank Corporation, including, but not limited to, Manufacturers and Traders Trust Company, M&T Bank, Wilmington Trust Company, WTC, operating in Delaware only, Wilmington Trust N.A., WTNA, Wilmington Trust Investment Advisors, Inc., WTIA, Wilmington Funds Management Corporation, WFMC, and Wilmington Trust Investment Management, LLC, WTIM. Such services include trustee, custodial agency, investment management, and other services. International corporate and institutional services are offered through M&T Bank Corporation's international subsidiaries. Loans, credit cards, retail and business deposits, and other business and personal banking services and products are offered by M&T Bank, member FDIC.
Copyright 2022, M&T Bank and its affiliates and subsidiaries, all rights reserved.
Private market investments are only available to investors that meet the U.S. Securities and Exchange Commission's definitions of qualified purchaser and accredited investor.